Hello everyone, in this video we will talk about Gaussian integral. Now what is Gaussian integral? It is an integral of f of x equals to exponential minus x to the power 2. Now if you put this thing in ChatGPT, you will get it as a form of a result that is a very well-known result. So this integral is equal to under root pi. This result is encountered in probability theory and statistics. And what this slide says is that the proof of this involves use of polar coordinates and complex analysis. In this video, we will look at what is this slide talking about polar coordinates and this complex analysis. What is this complex analysis? And let's start with that. Now, 3 points you have to note are: number one, integral of f of x with respect to dx is I, then I square is equal to integral of f of x multiplied by f of y with respect to dx dy. Second thing you need to notice, it is a well-known step. When changing to polar coordinates from x, y to r theta, dx and dy changes to r dr d theta. This involves understanding of Jacobian determinant. And third well-known step, the well-known trigonometric property, that is sine squared theta plus cos squared theta equals to 1. Now let's look at the steps of the problem. So we again come back to this. I is equal to integral of e to the power minus x square. Now if we change it to I square, we get e to the power minus x square minus y square. Then changing to polar coordinates, x changes to r cos theta, y changes to r sin theta. Then I square becomes, so one thing we need to note is that when x goes from minus infinity to positive infinity, we need to cover the entire plane. So r is basically radius and theta is basically angle. So when x goes from minus infinity to plus infinity, r goes from 0 to infinity. And when y goes from minus infinity to positive infinity, theta goes from 0 to 2 pi. This covers the entire plane. Now I square becomes integral of the integral I square becomes limit 0 to 2 pi, integral 0 to 2 pi, 0 to infinity, second integral opens, exponential minus r square cos square theta minus r square sin square theta. Now we'll use the trigonometric property here and set sin square theta plus cos square theta equals to 1. So this leaves us with I square equals to double integral of exponential minus r square r dr d theta. So I square is equal to, so over here we separate out, there is no term of theta in this thing. So we separate out the integral of with respect to d theta, and that becomes 2 pi. And the remaining integral is with respect to r, which is 0 to infinity exponential minus r square r dr. Now we change r square to z, so we differentiate it. 2r dr becomes dz. Then in this slide we are using a well-known result that e to the power x, integral of e to the power x is equals to e to the power x itself. What follows from this result is that integral of e to the power minus x equals to minus e to the power minus x. Now we'll use this property in a bit. So we come back to I square. I square equals to pi. I square equals to pi 0 to infinity exponential minus z dz. Then using this property of integral of e to the power minus x equals to minus e to the power minus x, we put this value here and set the limits, apply the limits of 0 to infinity, then changing from infinity. So this value of this at infinity in minus value of this at 0. So negative and negative would become plus, and this is 0. This equates to 1. So I square equals to pi, and I is equals to under root pi. Now this is a very well-known result that is used in, that we'll see being used a lot of times in probability theory and statistics. The use case which came to us was for machine learning, and in a video coming very soon, we'll look at where we encounter this result. Thank you.